Hi. Good evening, Trisha. Prisha, so how has your couple of weeks been? I am very sorry. I have been very busy with work in the last week, and I have not had time. And the week before that was illness. I'm very sorry. I know that you wanted to complete the syllabus as early as possible, but things have been a little bit chaotic and a little bit tough the last tight, so to say, not tough, tight in the last couple of weeks. So now the good news is this: I do have the next 2 3 days quite widely open. The question here, which I have regarding your timings, is this: what are your general timings with respect to sleeping, waking, that type of thing, basically?
Tomorrow,
Because I will be busy fully from 10 to, let's not call it 10, let's call it 9 o'clock in the morning till say evening 6:37. I will be tight. That is, other than that, I'm free. So, what timings can work?
after 6:30 is fine. Or tomorrow.
Tomorrow after 6:30 will work for you. Sure.
Yes.
Okay. Okay. And all right. Till what time will be feasible tomorrow? 6:30 say like it.
Um, 8:30.
8:30. Okay. All right. Let's try.
Until 9 also. If I don't have physics class tomorrow, then
Hmm.
we can extend like.
Okay. Okay. All right. So before we start off, I want to have a quick list of the topics which are left over for discussion overall, so that I have an overall list to basically start ticking through. So, can you give me what topics are left over from a discussion point of view, list type of thing?
Like in this chapter, you are asking.
Give me total itself. Let's aim for total itself.
Um, uh, इलेक्ट्रोकेमिस्ट्री के बाद वो डीएफ ब्लॉक का हाफ पार्ट इज रिमेनिंग
So
then
chemistry and then D and F block NCRT ka part over there regarding the oxo ions.
then
Hmm.
like
Hmm.
we can brush through physical chemistry once.
Which parts of physical chemistry? Because you have to be more specific than that. Physical chemistry, pura.
SCP, solutions and colligative properties.
Solutions and
Colligative properties.
okay, all right, okay. So solutions, we'll have a quick brush up on that. All right, and any other topic?
No, इतना ही है अभी तो.
I think organic maybe thoda baki tha, which was acids and bases.
That order of reactivity.
Carbocations, etc. GOC basically. Okay, all right. और क्या बाकी था बेटा?
अभी तो इतना ही है.
अभी तो इतना ही है. All right, so all right. Let's continue here. So इसमें we have discussed ionic to an extent, correct? Ionic एक जगह तक हो गया है, and electrochemistry में then you should be having a lot more clarity by now, right? You have tried out. Let's see. So what do you want to discuss today, beta? So we have electrochemistry का जो भी है, D and F block CRT, solutions and organic. These are the main things. Okay, all right. So let's continue on with electrochemistry, or which topic do you want to discuss today?
The cells we can do or dry cell wala part.
Okay, so you want to continue with electrochemistry and usme discussion on cells. Okay, all right. So you want to continue with electrochemistry, correct? Okay. Now then let's. Okay, all right. So we will start with electrochemistry. Fine. So electrochemistry, ma'am. Can you now go into? You mentioned something about cells. What other topics do you want to discuss? in this
We
chapter?
have dry cell, lead accumulator, and fuel cell, and we have molar conductivity और कोल रोशेस लॉ भी है
Hmm.
तो इतना ही बचा अभी तो
ओके, सो बाकी जो भी है तुम्हें आता है ऑलरेडी, इज इट करेक्ट, इस चैप्टर में?
yes you taught actually last lecture
ओके, एंड मुझे याद नहीं है एग्जैक्टली कि क्या क्या टॉपिक्स खत्म हुआ था बेटा, सो दैट्स व्हाई oh, I'm not sharing screen yet. Okay, that was stupid of me. Let me start sharing the screen. Yeah, sorry, I was writing it down. I was assuming I was sharing screen. Uh, yeah, Dikran?
हाँ
हाँ, so electrochemistry, उसमें cells, dry cell, fuel cell, molar conductance. What else is what are the other topics which you have in the chapter which are pending?
कोल रोशेस लॉ
Cole-Roche's law, okay. And yeah, anything else?
um conductance in solutions
Basically conductance. Conductance में एक discussion.
हाँ
हाँ, ठीक है. And up to what depth? That is why I want to know what exactly do you need there. Conductance में एक discussion. What all are there? Small subtopics क्या क्या तुम्हें है syllabus में? वो मुझे बोलो, बिकॉज मुझे मैं कंडक्टेंस में घुसूंगा तो घुसूंगा अंदर. सो if you give me the
like
subtopics which are there, there will be like guidelines along which I should go.
um con except
Hmm.
we have like that formula the
Hmm?
वो जो फॉर्मूला है उसके ऊपर ही क्वेश्चन आते हैं जस्ट लाइक डायरेक्ट फॉर्मूला
Tell me which terms.
वही स्ट्रॉन्ग इलेक्ट्रोलाइट वीक इलेक्ट्रोलाइट्स एंड
Mhm. Hmm.
against
Equilibrium constant calculation कुछ आता है कि नहीं?
नहीं मैंने आपको पीवाईक्यू भेजा था तो
ठीक है, मैं देखता हूँ. Can you highlight the messages and send again?
Yeah.
Anyway, in the meantime, just tell anyway. What exactly are the other subtopics you have?
In what?
Other subtopics you have in this topic, in this chapter here.
That's all.
Hmm.
Yeah. इतना ही है.
इतना ही है. ठीक है. Galvanic cell. So let me just directly go to WhatsApp and have a look here. That will be easier. So maybe here. Okay, so electrochemical cells may you guys have. These are the toughest questions you guys face.
These are actually PYQs.
These are the toughest questions you guys face normally.
I find it tough, but I don't know about others.
I'm asking honestly. Just give me a realistic estimate so that I'll know where
I
basically
haven't actually solved all of them.
you've solved all of them, is it? These are
No,
like
I
roughly what to say, like 70% then.
no, I haven't solved any.
Oh, you haven't solved all of them yet. Okay, all right. Okay, all right. I see where roughly the level is at. Okay. Hmm. Okay, so where did we discuss till last time? I remember we had discussed about potential last time. So did we talk about what is meant by reduction potential? What is meant by oxidation potential? What is meant by potential in general? We talked about it.
Yes.
Okay, and did we discuss delta G and potential, or where did we go?
Yes, we did.
We discussed delta G and potential, correct?
Hmm.
Okay, so I discussed the relationship between delta G potential and Nernst equation. Somewhere till there, is it?
Yes.
And the RT by NF, wala, that derivation was,
Hmm.
I suppose, yes.
Hmm. Yes.
Okay, and okay. Okay, so we are at like 1/3 of the story right now. ओके, तुम्हें कंडक्टेंस भी है बाकी. ओके, ठीक है. I think I have a reasonable idea as to where things are. Questions के हिसाब से it is not that complicated of a thing for you guys, honestly. But हाँ, if you want to understand, it will be a good fun thing. But I think we will limit our conversation with respect to this set of PYQ here. So the PYQ is like at least this is a proper full complete PYQ. Yeah, is it going to be like incomplete?
नहीं, full है.
All questions are there.
Probably. रहेगा most of the questions.
All possible questions in the exams which you write are here, correct?
हाँ.
Okay, ठीक है, चल दो. चलो, we will continue on with the discussion here then. So cells, dry cells and fuel cell में तेरा issue है थोड़ा बहुत, and यहाँ पे भी है. And okay, all right. So let's start off today's discussion now, beta. So let's continue the electrochem. So electrochem is what you want to continue on, correct?
Yes.
ठीक है, okay. All right. Let me first. Do you remember when we had the last session, Gana? Last week, na?
Or last Sunday.
Last Sunday, that was on electrochemistry?
हाँ.
Okay, so that should have been 8th, I suppose, correct?
Yeah,
Time was your class, morning or afternoon?
yeah,
Afternoon,
that only 2:15.
अरे, let me quickly see क्या क्या हुआ. That will give me a better understanding as well. Okay, so we had discussed what is the reference there, how do we calculate. Okay, potential क्या है पूरा discuss किया है. Okay, we talked about electrolytic and electrochemical as well. Okay, all right. We had discussed the delta G link over there properly. Okay, all right. Then we had discussed this also. Okay, we had discussed the potential aspect. What is the Nernst equation? Actually, I'll continue the discussion here itself on electrochem. This will be easier. Okay, so net useful work done. ये भी हो गया काम. And ये भी हो गया. Okay. Okay, so now according to what I saw next, we'll have to talk about what is going to be a cell, which is basically what you mentioned exactly. So let's continue there. So when we are talking about an electrochemical cell, so if I'm talking about an electrochemical cell, An electrochemical cell is going to be something which is going to be one which produces electricity. So when we talk about a Daniel cell, this is going to be a typical electrochemical cell. So Daniel cell is going to be an example of a typical electrochemical cell. All right. So when we talk about an electrochemical cell, in the previous session there, over here, as you can see in this part here, we had talked about how an electrochemical cell is generating electricity, which basically means delta G is negative for it. And of course, the E naught of the reaction is going to be positive for it. So when you're going to be having an electrochemical cell, it is going to be something where the delta G for the cell reaction has to be negative, which will automatically lead to the electrode potential, not necessarily at naught condition, sorry, the electrode potential of the reaction, cell reaction, being something which will be positive here. So far, is this clear, Kana?
Yes.
Okay. So we are going to be having delta G of the reaction being negative and the E of the reaction, the electrode potential of the reaction being positive. How are they linked up? They are linked up by this equation. Delta G is minus NF into E of the reaction. So in this case, delta G of the reaction, or we can think of it as delta G of the cell. Now, when we say cell, what is the idea of calling it a cell? The idea of calling it a cell is basically, it is the easiest way to measure. Say, how did all of this start? All of this actually started not because scientists were looking to exploit electricity. See, when we started doing all of this, we didn't know how electricity was going to be useful for us. We were scientists at that time. They were just experimenting because this was being useful in some other ways. For instance, in this particular case here, this delta G of a reaction, these things over here are actually, the electrode potential actually started off as a way for scientists to study chemical reactions. That is, advances in electricity started happening from chemistry actually. So when you look at physics over there, physics may a full branch, multiple branches have opened up in physics through chemistry basically. So what happens over here is, this is going to be the starting of how electricity was discovered, or rather how electricity was used in the beginning, because electricity was like the niche experimental thing which people do not normally have time. So that was used only by scientists at that time. They were studying chemical reactions using electricity. So what this E of reaction was doing was, it was quantizing the tendency of a reaction to happen. So E of a reaction basically is going to be nothing but it quantizes the tendency of the reaction to happen. When I say reaction over here, I am only talking about the forward direction of whatever reaction we are trying to consider here. So when I say this particular tendency of the reaction to happen is being quantized, that basically means we are quantizing the tendency, yes, of the forward direction point of view of the reaction to happen. So far is this part clear, Kana? Or do you have a question over here? Any doubts over here so far?
No.
Show me your face, because ultimately I can't decide based on just your voice. So what questions do you have over here? Do you have proper understanding as to what we have discussed so far?
Yes.
You understood what I mean by quantizes over here, correct?
Yes.
Okay. All right. Now, all right, let's come back to the next part over here. So this is going to be what we are trying to do over here. So the delta G of the reaction here is something which they could measure in this case here using. So what they were trying to do was, this particular E of the reaction is actually a way to measure this particular thing. A chemical reaction was being studied where they tried to study these chemical reactions based on the tendency of the reaction to happen. So when scientists started studying how a chemical reaction happens. Or other chemical reaction, why does it happen? So when you start studying why something happens there, you have to start studying effectively what there. You have to start studying tendency for a change to happen. Correct? You have to start studying tendency for a change to happen. For instance, let me explain this a little bit more clearly here. If I'm considering, say, a chemical reaction. Okay. Now, imagine you're a scientist. You're studying a chemical reaction right now. So when you're studying a chemical reaction, you want to know why this particular reaction is happening at some point of time. You'll study, say, multiple things about it. You'll want to know why it happens. But when you want to know why it happens here, this is going to be having a unique reason for why it happens, correct? Each individual reaction which happens has a unique reason why it happens. Correct or not? Think. If I'm going to be looking at a combustion reaction, the combustion reaction has a different reason of why it happens compared to, say, a melting of ice. So every chemical or physical reaction, if I'm going to be trying to consider why that particular change is happening, chemical reaction is actually something which initially they started considering for physical and chemical. But if I'm studying a chemical reaction and I want to understand specifically why it is happening there, I need to start having some kind, if I want to start that study even, I need to have some kind of a metric. That is basically what your electrode potential series basically starts off from. I think we had talked about this in the previous session also partially. So I'm assuming this part here, we are going to be clear on. Yes?
Yes.
Okay. Now, the next thing here is going to be, when you're going to be looking at producing electricity here, you're going to be having only certain types of cells being meaningful. For instance, this Daniel cell which we had over there was something which was capable of producing electricity. That was the first one which was basically used. So can you tell me a little bit more about the Daniel cell? Do you have Daniel cell in your syllabus?
Yes.
What do you know about the Daniel cell, beta? Can you tell me what is the anode there? What is the cathode there? And let's proceed. What is anode in the Daniel cell?
Zinc
Zinc.
and cathode is copper.
Now, when you're mentioning things, you have to mention with their physical states. So zinc what?
Zinc rod, solid.
And cathode is?
Copper, copper solution.
Cathode is copper solution or copper rod?
Sorry, rod.
Okay, all right. So copper solid. Now, next, what are the electrolytes? What does the electrolyte do? Is it a common electrolyte, or are they two separate electrolytes? Are they two separate cells? Is it one cell? How is it?
Separate electrolytes. Uh, Zinc salt ka solution and copper salt ka solution.
Okay, let's first, if you want to give Daniel cell in the most efficient manner, instead of giving information in this manner where each thing is being described, what is the best way? There's a cell representation, correct?
Yes.
So let's directly go to that. Give me the cell representation for Daniel cell and explain the parts. Start.
Sudden, like the reaction should I tell?
Okay, Zn.
Zn plus Cu2 plus gives Zn2 plus Cu.
Okay. Okay. All right.
And then Zn is in solid state and Cu plus 2 is aqueous. Zn2 plus aqueous. And
Okay. This is the reaction. I ask for the cell representation. How should I represent the cell in this particular case here? Are you familiar with cell representation?
Yes, yes.
So let's have a look at some of the questions over here. It looks like they are not using cell representation much.
It is there
Yeah,
on.
yeah. So let's take this and let's talk about this a little bit. So in this here, as you can see better, they are using a proper representation for a cell. So you're going to be having this part here being the one which represents the oxidation, correct? So in this case here, in the current cell, Daniel cell, what is the oxidation reaction?
Zn became Zn2 plus.
Good. So we're going to be having zinc slash zinc plus 2, aqueous solid, being the way to represent the scenario over here. And we can also add one more here. You can mention comma ZnSO4. Effectively, you can mention by adding that comma ZnSO4, we are telling that it is going to be in the form of a salt, zinc sulfate. And you're also going to be having one more thing you can add as a tiny mention here, dilute H plus, because there's going to be a few drops of dilute H plus usually present in the solution here. Why do we usually have a little bit of dilute H plus? It helps in increasing the conductivity of the solution. It helps in increasing the flow of the ions in the solution. We'll talk about that when we come to conductance discussion. So conductance discussion, we'll talk about why H plus is going to be something. Adding a tiny bit of dilute H plus is very, very useful. So now let's, this is related to something called as Crothers effect. So if I forget, remind me sometime. Okay, this is something which is not necessarily technically, I don't know whether it is useful or not, but it could come out to be handy. It's a simple effect. Anyway, coming back to the point here. So zinc plus 2 is going to be in the form of zinc sulfate over here, in this particular case over here. All right. Now, the next thing over here, as you can see, there is two slashes. What does this double slash indicate, beta?
That they are in two different beakers.
Okay, all right. The double slash, technically, yes, that is basically what it indicates. You can also think of it as indicating a salt bridge. All right. The double slash can basically be considered as something which is indicating a salt bridge. And yes, another way of interpreting the same information is we can also interpret it as the anodic solution or the anodic half cell is separated from the cathodic half cell. That's effectively the idea over here. So the anodic half cell is separated from the cathodic half cell in this particular case here. So when the anodic half cell is going to be separated from the cathodic half cell over here, how is this going to be something which is going to be happening over here? Think, what is the reason why this is being done? What could be the reason? Why are we separating them? This separating them is basically making the process more complicated, correct? That is why we are having a salt bridge over here, correct?
Yes.
So why, what is the purpose of separating? Why don't we try to have all of it together in one bunch? What's the purpose of separating them? What do you think could be the purpose of separating them?
Continuity of the reaction.
Salt bridge is there for reaction to continue. That part you are correct. You have memorized that about salt bridge from somewhere, and your brain is saying it might have something to do with this. You're not wrong about that part over there. But that does not have much to do with what I'm asking here. What is my question related to? My question is not asking how we fix the problem which happens because of separating them. You understand what you are giving me as answer here?
Hmm.
So you gave me the answer that if I'm going to be having a problem which happens because I'm separating the anodic half cell and cathodic half cell, that problem can be solved by using the salt bridge. And what is that problem? That problem has something to do with the flow of electricity or electric charge. Correct?
Yes.
Okay. Flow of electric charge through the circuit which is helping us measure everything. Now my question goes to this. Why did we separate them in the first place? We have to have gained something in the process now. What did we gain by separating them? We had to add some extra things which made everything more. What are we gaining over here? What are we doing? What did I tell you we are doing in all of this process over here? What are we trying to do? I have a box originally where there is a chemical reaction happening. I am a human being. I want to study this box. Why do I want to study this box? I want to study this box so that I can make the box useful to me. Whatever is happening inside, I want it to be useful to me, as useful as possible. So, in the process of studying it, I have realized a few things. Things can be useful. But imagine, let's take your classes. Let's take your classes. Classes can be useful and not as effective or as efficient as well, correct? Yes or no? Right? That is
Yes.
the simple reality of the situation. So that is going to be something which is in non-negotiable, really. But at the same time, what is the way to make them better? You take control, complete control in your hands over the way to basically design your classes, your schedule, exactly correct?
Yes.
Is that not what you are doing? Is that not what your mother is doing for you, or you're helping you with? Right? This is not something which is happening by just one person. It's happening to a family, right? Correct?
Yes.
I know it is not something which is easy. This is going to be involving a lot of juggling of everybody's time. Now, the question is, why? Why did you do it? You gained more control over it. In terms of, when I say more control over it, you gain more control over the change which is happening now in you, and which is going to be happening to you soon. So you are gaining more control over the reaction because you took control over the reaction at every stage. And when you take control over the reaction at every stage, you can control the product more properly. Correct? Is that not what you have done?
Yes.
So if I'm going to be looking at a chemical reaction, if I want to do the same thing for a chemical reaction, what should be the equivalent part of it? What should be the equivalent of it? If I just try to show you how the metaphor would be in, what to say, the change which is happening here. So if you consider your full change through this 11th and 12th standard as a chemical reaction, all right, what have you done? You have basically taken control of the small parts of it as much as possible, so that you can as efficiently get control over the final product of the reaction. Correct?
Yes.
You understood that? I want to see your face actually, because this is a question which I have right now. So I want you to metaphorically understand this as well. So did you understand what I'm trying to describe over here to you?
Yes.
So what I want you to think now is, in a chemical reaction, what will that translate into? What do you think that will translate into?
Like flow of current, so that current can be used.
So your brain is going towards flow of current somewhere, correct?
Yes.
So now, what does flowing current give you? What is the advantage which that gives you? When you change the reaction and when you make it into a circuit, by separating it, we are making it into a circuit over there, correct? What is the biggest advantage that it gives us? Making it into a circuit. What's the biggest advantage of having a light in the form of a switch over a lamp, other than the fact that it is cheaper and more energy efficient to the environment, less polluting, all of that is there. Other than that, all of that, what is the main reason an electric bulb is more preferred by a huge margin compared to a diya?
You can control it, like when you want to.
You can control it. That is exactly, you can control it better. Literally, correct? That is a
Yes.
blunt thing. You can control it better. So, what does separating the two halves of a reaction do? You get like extreme control. You can stop the reaction exactly when you want. Basically, in every cell, you draw that key, right? Just for the sake of drawing it. Why do you draw it? Why do you draw it? Have you ever thought of it? That was the thing which the scientists could control. That key was the entire purpose of that experiment. The entire experiment was done so that that key could be put there, so that we could switch on and off the reaction whenever we wanted and control every bit and part of it, and we could study it in extreme detail. When I'm having a reaction happening where I can control when I start and stop it, what does that give me? What can I do then? Think of it like this. I'm trying to study a chemical reaction, Karam. Okay, I'm trying to study a chemical reaction. This chemical reaction, I want to see what's happening inside the box. Okay. So if I want to see what's happening inside the box, how do I find out what's happening inside the box? I'll have to use some mathematics. I'll have to use tricks. So I'm first going to be looking at what to say in this particular case here. I forgot where we were talking about. This goes into equilibrium. My brain went there. I'm sorry. What was the point I was trying to explain here, Kana? Can you bring me back on track?
की के बारे में
Hmm?
कि like control the reaction.
Controlling the reaction. Okay. So the circuit over here basically allows us to control the reaction perfectly. So because the circuit can allow us to control the reaction perfectly, we can then study the reaction at every instant. Like I can say at this point, this much of the reaction has only happened because I only switched it on for this much amount of time. You understand the idea over here? So because I can control, I also know how much is being sent in. So controlling also means measuring exactly what you're doing there. Give me a second. Let me turn on the light here. Yeah. So in this particular case here, the control basically also means we are literally having what to say, the ability to know how much is going in and out also. Literally counting what is going to be happening in a reaction. Of course, this level of understanding and control was only possible when it came to reactions of one type. What type of reactions could we exert this kind of control over? Reactions which involved electrons. Can you tell me what those reactions are called? Because Technically, only those which are involved in that flow of the electric charge we can control, correct? Right.
Yes.
So only the reactions which involve electrons, we can turn on and off. We can basically switch it on. We can separate the two parts because this part has to exchange electrons with this part. Physically, they have to exchange stuff for the reaction to happen. So how do I control? I separate them out completely. And then I give them only one pathway through which they can connect. You understand what is the idea over here? So this part of the reaction and this part of the reaction technically are going to be interacting with each other. But they are not interacting directly right now. They don't look like they are interacting directly. But they are actually interacting directly. Some stuff from this is interacting with some stuff from this. It is just through a path which we cannot see. So what is being transferred around? Electrons have to be moved around. What are these reactions where electrons are moved around? Redox reactions.
Redox.
So the only type of reactions which we can actually chemically control, the chemical reactions which we can control, where we can exert a lot of control over the chemical reaction, those are the reactions which we can study in greater detail also. Because reactions happen too fast. If I want to study, how can I study something which is happening so goddamn fast and understand it properly? You understand what I'm trying to tell you over here? Say, for instance, what is the reason why you are taking this kind of individualized classes? Mainly because the regular routines which are available in your place are not sufficiently suitable in some way or another with respect to what your preparation requirements are, correct?
Yes.
I mean, either somewhere or another, I do not understand, or rather I cannot claim to understand what is not fitting, but in some way or another, if I consider what is available in your vicinity and where your circumstances are right now, they are not exactly merging perfectly. So you require a little bit more from the outside over here. In a similar way here, when you end up having a reaction where you know there is a point of issue, you can then start controlling it. That was what electrons were. So when scientists were looking at a reaction and they were trying to see how to control reaction, they had to really go in depth over there to see, and then only they could control the reaction. And basically, the person who will know what to say themselves best is yourself. You will know your own requirements best. So it's always going to be best when you're going to be having what you're having, whatever you're doing now. Basically, I take the role of, I suppose, a personal tutor, correct? Somebody who basically, wherever you see in your whole picture, jahan pe gaps hai, serious gaps hai to serious hai, kam hai to kam hai. But somebody has to have a clear picture of the whole and then fill it up, correct? But that requires somebody who has a fuller picture of the whole thing. And somebody who has a full picture of this and somebody has a full picture of this. You have a clearer understanding of who you are. I have a clear understanding of the subject. So we can merge them together cleanly over here. You understand the idea over here? So effectively, when scientists started looking at reactions, they had to look at, I want to combine, I want to understand reactions, I want to study. They started seeing control was necessary. Then they started saying, oh, electricity is something which I can try to marry with this. This was electricity starting. Then electricity and control basically merged together. Then they realized, oh, this is win, 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 win. Let's now go electricity fully. And they started going deeper and deeper and deeper into electricity. That's basically how electricity started developing as a field. And from where electricity was being used to study chemical reactions, it became the other one which started dwarfing completely. So initially it was like chemical reactions was being married with electricity. But then electricity became so goddamn big, it just blew everything out of the proportion over that. Electricity was a small one there at the starting. Chemical reaction was the big one. And they were chemical reactions were the big field. They were being merged together. Then when electricity took off, you can see where electricity has gotten us. So yeah, that was like that's basically what I was trying to anyway talk about over here. Let's come back to the chemistry of it now, and story se nikalte hain.